Here is the Athenaeum from the southwest, as it might be viewed from one of the student residences. This is our final lecture, and it gives us a chance to wrap up some of the concepts we've introduced, to show you where we need a lot more data, to reintroduce really, my own ideas about the difference between outside-in and inside-out pharmacology, to thank several very key people, including yourselves, who've helped to make the course smooth and lively and accurate, and to tell you about the next steps in your career. During the first 3 weeks, we introduced the concepts and tools. We talked about an introduction to neuroscience. We told you about drugs as chemicals with access to the brain, about receptors as proteins, about proteins as possible drugs. We introduced the study of the nervous system, dose-response relations, and electrophysiology. Then we went on to talk about drugs as activators and blockers of ion channels, especially at synapses, but also in axons. We also discussed drugs and their actions on G-protein pathways, both immediate and long-term, several G-protein pathways. We discussed that drugs act on neurotransmitter transporters as well, and we wrapped this up by giving you a feeling for how drugs act recreationally in various parts of the brain, various types of drugs. Then we moved to the intellectually incomplete parts of the course. Neuroscientists have been willing to admit that we don't understand the causes of many neural diseases. I think we have been less willing to admit than we should that we don't understand basic mechanisms of important neural drugs. And so we talked about mechanisms of nicotine addiction and what we know and what we don't know. We had to omit studies of opioid addiction, cocaine addiction, and alcohol addiction. We went on to talk about drugs for neurodegenerative diseases, Alzheimer's and Parkinson's. We had to omit, for lack of time, amyotrophic lateral sclerosis, and frankly, there are no satisfactory drugs yet for ALS. During the final week, we have talked about drugs for psychiatric diseases, major depressive disorder, bipolar disorder, schizophrenia. We had to omit extensive discussions of anxiety disorder and borderline personality disorder. In general, we had to omit saying anything about migraine. We treated epilepsy only briefly, and that's really a shame considering that roughly 1% of the population does suffer from epilepsy. I'll remind you of an image that I showed you in one of the introductory lectures. It's Eroom's law. It is the fact over the last 60 years that it has become exponentially more difficult, more expensive to develop new drugs in general in biomedical research. Eroom is Moore spelled backwards, and so this is the opposite of Moore's law, in which it becomes easier and faster and cheaper exponentially over the same time period to do digital processing. I should point out that biomedical research has some aspects of Moore's law. For instance, the amount of DNA appearing in the databases has followed a Moore's law trajectory over this amount of time. But drugs have not. And this trend is especially true for neural drugs. Very few conceptually new, mechanistically new, helpful neural drugs have appeared in the last decade. In response, therefore, what are the next steps for the science of drugs and the brain? We have to admit that we know less than we assume about the science behind drugs and the brain. This allows me to tell you a bit about outside-in versus inside-out pharmacology. Now, in most texts of neuropharmacology, you won't find the term outside-in because all neuropharmacology, with the possible exception of bipolar drugs, assumes that drugs work from outside the cell and that their messages make their way over the long term to the nucleus, to the surrounding organelles, or from the membrane to the nucleus, and that's what causes the eventual therapeutic effects. I've briefly introduced the concept of inside-out mechanisms, which emphasize binding to the same classical targets, but within the endoplasmic reticulum and the cis-Golgi apparatus, you won't find inside-out in any textbooks of neuropharmacology, because, in fact, it's a term that I introduced only within the past year. I briefly mentioned some applications of inside-out neuropharmacology. The important point is that inside-out neuropharmacology distinguishes the drug target, which we know fairly well, from the drug mechanism. The targets in inside-out pharmacology are in a surprising place. Same classical targets, but they're in the endoplasmic reticulum and in the cis-Golgi. I've talked about possible applications to nicotine. There may be applications to opioid addiction. I've talked about neuroprotection as a target. Talked about the therapeutic lag with antidepressant drugs. A bit about the possibilities for inside-out actions in response to ketamine, and not at all about the therapeutic lag with antipsychotic drugs. So I have a lot to do over the next few years. What about you, the students? What's for you to do? Please complete the survey so we know better how to give this course the next time. Please take the remaining quizzes, which will qualify you to accept our congratulations on your statement of accomplishment. Please accept our thanks for participating in the forums. You've done a marvelous job. You've corrected errors. You've showed us where to put the course in terms of intellectual stance. You've helped each other an enormous amount. You've made a real community, and we thank you. Please join myself in thanking the course staff at Caltech and at Coursera. At Caltech, Bruce Cohen has done a marvelous job on the assessments, the embedded quizzes, and the weekly quizzes. Cassandra Horry has worked behind the scenes to make the course go smoothly. Leslie Maxfield, our Director of Digital Media, has organized a lot of the production. Alex Mikes has actually done the production of every episode. Crystal, our indomitable and cheerful forum curator. Jody Lee and Lynn Backley did important jobs on filming the cameos that I've showed you around the Caltech campus. Please continue to consult the book by Nestler et al. And for those of you who are beginning to launch your career, please consider a career in neuroscience research. And for all of you, you could thank me by supporting funding for neuroscience research for drugs in the brain in your own country. I hope to see you again pretty soon.